Okay, so in this part we're going to add some functionality to the actor that you just created. So the question is, what do we want it to do? And I thought it'd be a sort of easy first exercise for us to just add some basic movement to the actor. So one thing you probably want to do is go to the actor blueprint that you created in the Unreal Engine itself, and if you go to the static mesh component, you click on the static mesh in the components list there, you should have simulate physics switched on. Just click that to false because we're actually going to move it ourselves. So what we're going to do is we're going to modify this a little bit. Actually, let's just stick that in there because we're going to need it later. Okay, so the first thing we want to do is we want to have what I'm thinking is we'll just do a simple sort of sine movement. So what we need is a float value for current time. Now, one thing you should notice, let's just see if I can make that a bit bigger. There you go. Now, one thing you should notice is that there's a few things that are a little bit different here. Traditionally, you couldn't have an initializer like this equals thing in a header file. You'd have to do it in the constructor in CPP file. But now in modern C++, you can actually do an initializer, which is kind of fun, and I like using that. The other thing is that we probably want to be able to modify some of these. So current time is all right. Let's have a float for. Actually, is there a float 32? Okay, we'll have a float for now anyway. Oh, they're using float for a couple of seconds, so that's right. So, yeah, what I want to do is I want to make the box move up and down based on a sine wave, but I want to be able to change the sort of amplitude of that wave and also the speed. So let's we'll call that frequency. And we'll have another float called what the hell do you call it? Period, but I suppose magnitude. So, and before that, we need to store our start position. I'm not going to give that an initializer because we're going to initialize in the constructor, or rather in the begin play. So one thing you'll notice when you look at a lot of the Unreal Engine code is that there's this thing called a uProperty macro. And uProperty is a macro definition used by the header tool to sort of essentially automatically mark up a property, automatically mark up a data field or something. So any kind of field in a struct or in a class, uClass that is, you can mark as a uProperty. There's also uFunction, which does the same for functions, but we'll get to that some of the time. So the question is, how do we describe the uProperty? Well, in this case, we want it to be editable. So we put the edit anywhere and we give it a category. We'll call it movement. So you'll see you get this kind of little error from IntelliSense. Just ignore that because well, we're not going to use it. Or rather, we're not bothered about IntelliSense errors at this point, because IntelliSense doesn't know anything about that stuff. Now the question is, do we want to be able to edit the current time? Well, no, but we want it to be visible. So now it's visible but not editable. And start position, I suppose we could make that visible as well, although we don't want to edit that because that's just for code. So the idea of these uProperty macros is simply that it automatically annotates these fields. So if we look at our class here, you'll see there's a whole bunch of properties, right? There's a whole bunch of things expanded in here. Well, or if we select one of these guys, there's a bunch of fields that are available to edit. Now, what we're doing is essentially defining some new fields to edit, and this uProperty macro actually does that. And what it does is the external tool, the thing called Unreal Header Tool, comes through and finds these uProperty declarations and sticks it in the generated file, generated.h. So in essence, that generated.h makes available these properties to the C++ sort of engine code, which then displays them in these edit boxes. And that's a system called reflection. So it allows a function to say what are the properties that are available on this class, even though it doesn't know necessarily what that class is. It's only got a pointer to the sort of the very basic type, so the U class. It can say, okay, which properties, which interfaces, which functions do you export, and what are the parameters that get past them, and that kind of thing. So a reflection mechanism is really important in a modern kind of language, and unfortunately this has all had to be jury-rigged because C++ doesn't have that language feature. Whereas if you look at a more modern language like C#, it has all of this stuff built into it. So if you do any C# programming, you'll kind of be almost used to this kind of thing. But here it's been done by Epic instead. So let's get to actually writing the code for this. So first thing first, just make that a little bit bigger now. First thing first, it's usually useful to call the super function, basically the sort of the class this is derived from method first. And we're going to call start position equals get location. Nope. Get transform. Help if we could transform. Get transform dot get location. So what that'll do is it'll store the location part of the transform. The transform is, if I remember rightly, is an F transform. Yeah, an F transform is basically like the rotation and position, scale, etc. So basically the transform matrix and orientation F rotator, I think it is. We get the location part of that, which basically means the position. Why they called it location, I have no idea. And then we're going to do the actual code in here. So first thing we want to do is we want to current time plus equals delta time times frequency. So it's useful to comment this kind of stuff. So we want to be able to edit how sort of fast the thing moves. So we have this frequency variable here, and we just multiply that with the delta time, which is basically the time since the last frame. So usually it's a tiny little floating point value. And then we use that to Actually, we need a current position, don't we, really? Oh, should we do it inline? Let's add a current position. No, let's not. So we can do set location, just a bit easier this way. And it's an F vector, and we do not point not F. You notice me doing these not point not Fs. The point not F thing, make sure that it's a single precision floating point number, and then fmath sin current time. So we're taking the sine of the current time and then times magnitude. Oh god, didn't. Oh, my keyboard's playing up right now. So, is it set location? Pretty sure it's set location. Have I got my effector blah blah blah? That's the effector. Yeah, looks alright. Pretty sure it's set location. That's set actor location. Okay. See, here's one of the things that really annoys me about the Epic guys. They just don't get their naming correct. This is obviously an actor derived class, so set actor location seems like a reasonable thing, but okay, let's sweep as well. So that's the effector. Whether we sweep or not, let's call that true. Sweeping just means that if you like move the actor along through space, if you hit something it'll stop, which is kind of, well, do we want that? Yeah, I suppose we do. Sort of. We'll see if that works. If not, we can always take that true out. Okay, so save that. Let's put a comment in there. So magnitude is how much we want to move by from the starting position, and we've scaled it by frequency to give us control over the speed. And then just doing a sine wave. If you don't know about that kind of stuff, play around with it. And the other thing to notice is that this F vector is, we're only changing the Z value, which is the up axis in Unreal Engine terms. So let's save both of those. Now here's the fun part, right? We've just created some code. What we can do now is we can do what's called a hot reload, which means that we can reload that code. You'll see in the bottom right here, it compiles the C++ code and then actually loads it again. And what you should have just seen is that because I've got one of these things already selected, that category of variables just came up. And what that means is we can now edit those variables. So if I do a simulate, where's it gone? Oops. I think I might have done some... let's just have a look at this code. Oh, of course, I forgot to add the start position, didn't I? Silly me. Yeah, because obviously we want to like actually have our existing position, which we got here, and we're just adding an offset to it basically. Pretty silly of me. So we just compile that again and do the hot reload thing. Okay, so now when we run it, these boxes won't move, but if we, for some reason it forgets which one we're looking at, but if we up the magnitude and up the frequency a little bit, we'll see that the current time's incrementing, which is what we expect, but also we've got some variables. So the whole point of this is that it allows you to have properties in this sort of details panel, and this is all automated because of that markup code. It's all because we did this uProperty thing, and that's the real power of a lot of this stuff, is that you can make editors like this in a trivial manner by just adding properties and those kind of things, and which obviously means that your designers can have, okay, that's a little bit silly, but yeah, your designers can have a lot more fun. Let's just make something half decent, maybe change the speed of it a little bit. Now it loses these property changes when you stop, so what you'll have to do is do some kind of, you know, looking at the values there. It's a bit of a pain, but oops, that one didn't quite go to plan, did it? What was the size of that? A bit more, 150-ish. So now the important part of this is that when we run, no, that was a bit silly of me. Let's up the magnitude a bit as well. I want to do a scale of, say, 10 and 10. We can make stuff like this. We can make a platform that sort of goes up and down. Pretty interesting, eh? So that's an actor that we've added some functionality to. Be sure to save your map once you've edited and stuff. So just be aware that sometimes if you add certain things in this, when it does the compile thing, sometimes it won't quite work, and you might need to run it from within the run it as debug. Actually, we should probably go over that first. There are a few options for the different types of builds that we can do, but for now I would suggest you use debug game editor and Win64. Don't do a Win32 build because we need the memory. So make sure you've got debug game editor, Win64, and then when you run from a debugger, it'll actually open up a copy of the engine itself, so you don't want this running when you go to debug the actual code. So essentially what we've got now is that this has compiled the code, because remember that the Unreal Engine's actually, well, the Unreal tools are actually building the code. It's compiled the code and reloaded it for the editor. But if you want to debug, we generally want to run it from within Visual Studio, and that causes the editor to run and load up the DLLs from this build. So you should get a little, somewhere in the top right here, you'll get like little debug game thing that'll tell you that you're running debug game build. So you can also, if you go to debug, you can attach to process and detached to a process. So attached to process means that I can attach to the Unreal Engine that's already running. If it's running, you debug build and accepting connections. We'll look at that another time. So for now, I want you to just add that stuff and add an actor and just get it running so that you've got this moving platform thing, and then we'll start doing something a bit more interesting with components. So just carry on with that.